All right, cool. I'm going to get started then. Can I get a quick show of hands? How many people here are web developers, Django people? Okay, so there's a decent representation. How many people are doing scientific computing or more of the matplotlib type of stuff? Okay, and then anyone just developing tools and hacking around? And okay, cool. So I'm definitely in the last category there. I had never used matplotlib before like 2 days ago, but I tried to work it in here. I've been wanting to give this presentation for a while, but things always come up. So I am Ben Toews. I work at a company called NeoHapsis. We're a local Chicago consultancy. I am an application and network penetration tester. I break web applications and native applications trying to find security vulnerabilities. I also do a lot of research. In the past year, I've presented at DEF CON. I'm going to be presenting at DerbyCon in a couple of weeks. I did ThoughtCon. I've gotten published a few other places. And throughout all of this, I heavily use Python. I've been doing Python for about 10 years now, so it's kind of my weapon of choice. So I'm going to talk to you guys a little bit about concurrency. I don't know kind of what your guys' knowledge base is for this, but it's something that when doing networking and web application assessment tools I run up against all the time is how to send out 100,000 requests in a reasonable amount of time when talking to a web server or any other server for that matter, and doing any other networking. So concurrency in general is notoriously difficult to get right. It's gotten a lot easier recently, but it definitely has a bad reputation, and I'll talk a little bit about why that is. So concurrency is simply doing multiple things at the same time. So if you want to run a web server, for example, you have to be able to take more than one request at the same time, or else you're going to have a pretty hard time serving up to a large number of people. More specifically, you're trying to get around the problems when you have blocking. So things that normally block would be file access or file read and write, or network access, network read and write. So there's a lot of different techniques for this. I'm going to talk a little bit about some things at a high level, and then I'm going to talk a little bit more in depth about G-Event and Node.js, which are some things that I've been hacking on lately. So yeah, the options that I've worked with is multiprocessing, multi-threading, and event-driven concurrency. Multiprocessing, you literally have multiple processes, so you write an application and then you spin up multiple processes to deal with the incoming request or the outgoing request, depending on what you're trying to do if you're writing a networking application. All these processes are running in their own address spaces. This makes it a little bit challenging to do communication between them if you're generally you need to maintain some state across the processes to kind of keep everything organized. So there's a lot of methods for this. You can have files for communication. You can do sockets, queues, pipes. It's pretty messy. From my experience, I generally try to avoid writing any application that requires more than one process. There's a lot of easier options. Multi-threading. And I'm kind of going fast through this because I don't know how late people want to stay here. But if anyone has any, like I said, I don't know how experienced people are with this kind of development. So if anyone has any questions, feel free to interrupt. But multi-threading is another option. So multi-threading, you're doing time division multiplexing within one process. So you have essentially multiple virtual processes, and you're switching between them. And this happens completely in a completely invisible way to the developer. You don't have a whole lot of control of when execution is going to switch between your multiple threads. This is managed by the process scheduler. Here, though, as opposed to multi-processing, you do have shared address space and shared context between the multiple threads, and this makes it a lot simpler to write applications because you have the context between the threads, and you don't need to do so much fancy inter-process communication stuff. So communication is generally simpler, but you still have a lot of problems because you can't explicitly control when the process scheduler is going to switch between threads. You have to do things like locks on variables if you're worried about them changing between accesses when it might not seem like they normally change. You also have a lot of other primitives that are helpful, so queues and semaphores and events. Here's an image that I think kind of describes multi-threading quite well. Here you can see the process execution. It's switching between multiple threads, and these are essentially just multiple functions or methods or whatever that are running within an application. It's just switching between them, and this is somewhat arbitrary when these switches happen. So the thing that I've been playing with more lately, and the thing that's kind of been a godsend for me, and is event-driven concurrency. And the notion here is that it's somewhat similar to multi-threading, but you have a little bit more explicit control over when the switches between things are happening. And that turns out to make things a lot simpler. There's a lot less overhead in a lot of instances. So what a lot of this is built on is a library, a C library called libevent. And to read from their website, the libevent API provides a mechanism to execute a callback function when a specific event occurs or on a file descriptor after a timeout has been reached. Furthermore, libevent also supports callbacks due to signals or regular timeouts. Just in case any of you can't read, I thought I might need to read that. So yeah, if anyone's done anything with a language like JavaScript where there's a lot of callbacks, I think that this is a lot more intuitive. The notion is that you say, there's a TCP socket that I want to get data from. Rather than saying socket.read and just waiting and waiting and waiting until something comes along, you say, hey, call this function when there's data ready to be read from my socket. And then it calls the callback with the data, and you don't have to sit around waiting for the socket to become available to be read from. A slightly more developed interface for event-driven concurrency that is really nice in Python is called gevent, and this is what a lot of the things I'm going to be talking about are built on top of. Gevent is a coroutine-based Python networking library that uses Greenlit to provide a high-level synchronous API on top of the libevent event loop. And I think that that's about the worst description of a library that I've ever read. So I'm going to break it down a little bit. Coroutine is essentially a function. So you're spawning up multiple functions at the same time. So if you want to make 100 requests to google.com, you say at the same time, I want to send these 100 requests out. You're spinning these all up at the same time. And then only one runs at a time. But anytime you encounter a blocking, so network blocking or file access blocking, it's going to switch to the next coroutine. So you start execution in one coroutine, you hit blocking, you switch to the next coroutine, start from the top, go until you hit blocking, switch and switch and switch through all your coroutines, and you form a loop. And hopefully by the time you get back to that first coroutine, the blocking's done, the socket's ready to be read from, the file is ready to be read from, whatever the blocking was, and you wind up with this event loop, and it really simulates quite well multi-threading and multi-processing, because functionally you have these different coroutines, which are essentially functions, that all appear to be running somewhat simultaneously. And you get a lot of performance benefits because you don't have the overhead of multiple threads running or multiple processes running, and you also get some pretty, so you get some pretty good concurrency. Yeah, and the kind of the nomenclature here, we talk about greenlets instead of threads, and this is specific to gevent. Gevent is built on top of a library called greenlit, so that's not necessarily important, but something to keep in mind. I'm going to real quick hop over to some code. This is okay. So first, no, wrong one. Sorry, got too many files. Okay, so this is the use case we're going to be talking about. For those of you who don't do anything with HTTP, the request library is an awesome library. My ears kind of perked up when you earlier mentioned URLlib2. I spent many years battling with URLlib2, and requests will save you a lot of time in developing. It's a beautiful API, kind of like Ubuntu there, I think their slogan is HTTP for humans instead of Linux for humans or whatever. So it's a really well-designed API. Kenneth writes, who designed it, he works for Heroku. He makes really good APIs. So yeah, requests, basically what we're doing, we're calling out to my server that's listening on port 8888. We're sending it one parameter, which is I, and the server just responds back with whatever we sent it. So very simple, but we're trying to do it. Oh yeah, I have it right. So yeah, we're trying to do it 200 times is the only issue. So that's going to take a minute because we're making 200 HTTP requests. But aside from that, I think this is pretty straightforward. Oh no, I don't have internet. Yes, I do. I need to sign my soul away or whatever to... Need to sign in or sign a contract or something, I think. Maybe. No? There it is. Guest. So one of the most important things about networking, you have to be connected to the network. All right, so let's try that again. Okay, so hooray. That's going to take a minute to run. We're making 200 requests. It's relatively slow. So now I'd like to show you the G event example. Okay, so here we're still using the request library, which is one of my favorite APIs, as I've said. We're sucking in G event, and then we're doing something called monkey patching. So in order for this whole notion of evented concurrency and whatnot with G-event to work, all the things like the sockets and the other blocking APIs need to be patched. And that's so that when they hit the blocking, they know to yield to the next coroutine. So if you go and look at the G-event code, it essentially re-implements the socket library. And when I do the monkey.patch, all that does is it goes in and it replaces all the libraries in memory. So that makes it friendly for G-event. I specify my URL. Here, as I was talking about earlier, we have greenlets. So we're going to spawn with G-event the same method, request.get. So we're making a HTTP GET request for I in 2000. I think I'm running off the screen here. For I in range 2000. 200, excuse me. So we are here, we are making 200 greenlets, each of which, when started, will make an HTTP request to my server. And then what we do to kind of launch all those to make them run at the same time, we say that we're going to join them. And this starts up that event loop. It yields to the next coroutine, the next greenlet, and so on and so forth. It will go in that big loop, making these 200 requests, and print out their responses. So the synchronous one finished. Oh no. I didn't make my sacrifices to the demo gods. Oh, internet stalled. Oh, whoops. Finished while I was... I shouldn't have looked away. Oh, yeah. So this one isn't printing out as it's going along. But you saw that that took, about a second as opposed to the... when I was playing around with it on my home network, it was taking about 15 seconds to do it synchronously. Asynchronously, it takes about 1 second because all of those requests are going out concurrently. So when you're talking about for a lot of the tools and whatnot that I develop, where I'm having to send out hundreds of thousands or millions of HTTP requests, that type of performance increase is incredible. For you, if you're going and scraping the MLB's databases, I mean, if you don't want to sit there for 10 hours while all that data is getting pulled, something like this can save you a whole lot of time. But still, I think that this is a little bit ugly. So the same guy that made that other API that I really liked wrote a wrapper around that and a wrapper around G-event for doing HTTP in specific called G-requests, and that's just a wrapper around G-event, or around requests that uses G-event. So here you can see the API is a little bit nicer. We just do G-request.get for I in range 200, and then we do an iterative map over these and print their responses. So if that makes sense, I think it looks a lot cleaner and it's a lot less typing to do. And because it's iterative, it's actually a little bit more performant because we can be processing the response from the first response that comes back while other responses are outstanding, whereas with the G-event one, since we were joining all the code routines at the same time, we have to wait for them all to come back, whereas this we can start doing our processing ahead of time. So here you can see again, when you're doing it concurrently, it's quite performant. Alrighty. So that is, I think, one of my big use cases for G-event, and it's something that I've developed a couple tools that I've published, and it's, I think one of their main features is that they're very performant and very fast. And those have been using G-event. Another really cool thing, I know this is a Python meetup, but I've got to talk for a minute about Node.js. Node.js is something that's pretty awesome. Someone thought it would be a good idea to run JavaScript on servers as opposed to in your web browser. I think it turned out pretty cool. So what they did is they took Chrome's V8 engine, which is the JavaScript engine, and they added a bunch of APIs for doing system stuff, and then you run JavaScript on the server side as your server or whatever you happen to be doing on the server side. So yeah, I'll show you a quick example of what the code looks like for that. Yeah, I'm hovering right over it. So, and this is more of the traditional libevent style workflow where it's all callback based, whereas G-event was coroutine based. So here you'll have handlers. So for example, we're going to be down here making our HTTP GET request to the server 200 times. And then we have a handle function that handles our response. So as soon as each one of those responses comes back to the computer, it will call the handle function, the handle response function, pass it the response, and then you can do whatever you want with that. Within that, I then say that when data comes in on that socket, I want you to call this other handler, my data handler, and I want you to log the output. So if we run that, it's actually even a little bit more performant than the G-event and G-request examples. Oh, if I... Wait, I can't read that with Python. So yeah, pretty quick. Once again, though, this looks ugly, and I don't like that. I'm into good-looking code. So for those of you, I don't know if anyone here does front-end stuff, but if you ever have to write JavaScript, you shouldn't do it. You should write CoffeeScript instead, because it looks a hell of a lot better. So here's what CoffeeScript is it's a syntax that compiles into JavaScript. So think about how C compiles into assembly. There's a group of people who feel that JavaScript is the assembly of the future, and we'll be compiling everything into JavaScript. So here's the same exact code in CoffeeScript instead of JavaScript. You have list comprehension, the same HTTP API, some more Ruby-ish syntax actually, but here's your callback for the response. You are again setting the encoding, and then here's your callback for the data. You're again printing the data. That's going to look exactly the same as the JavaScript example I just gave, so I'm not going to run it again. But that's kind of the overall gist. Those are a few of the popular options for doing concurrent stuff. In Python, there's a few other options. There's, I think, a more low-level libevent wrapper that I've played with a little bit, and I thought it kind of sucked. There's also Twisted that I know a lot of people build web applications and other servers on top of. And I found that to be very heavyweight. I was trying to do something really simple like send out, a million web requests, and I had to spin up this crazy big framework with all these moving parts and stuff, and it gave me a headache, so I stopped. There's also one of the other popular things for especially doing stuff like what I do is a lot of people write stuff with Event Machine in Ruby. I'm not a big Ruby person, but it is a pretty nice API, and it's a little bit more of the callback style, the traditional libevent style evented concurrency. I promised that I would talk a little bit about matplotlib, so I have a really contrived example of how to use it. So I wrote up a little Flask app, and what this is doing, if folks are interested, I'll show one of the tools that I actually use a lot of this concurrency in. It's for doing SQL injection, really fast for doing blind SQL injection exploitation. And just for fun, I wanted to see a histogram of the response times for all these, hundreds of thousands of HTTP requests. So I built a little Flask app. You post to it response times. So it accepts response times, and then it does histogram of it. So we've got our plot.hist. We feed it the data. Give it some labels, make it look pretty. Then, I don't know, there's probably a better way to do this for people who actually use matplotlib, but what I did is I made a string IO, which is essentially a file-like object that you can treat as a string, and I wrote the figure to the string, and then I just base64 encoded it and spat it out in HTML as a data URL and an image tag. So that's probably not the best way to do that. It's kind of a hack, but hey, it's only one HTTP request as opposed to having to send out requests for all the images. So I've got that spun up over there, and then I wrote a quick patch for one of my demos that after each request will make another request to my local plotting server to log how long it took. So like I said, a pretty contrived example, but I think it makes pretty pictures. So I like it. So, and you can see because it's having to make 2 requests for each request, it's going to take a second longer. But, so now we've got our hello world data. The network here is not as nice as my home network apparently, because I had a nice normal distribution. But I don't know. I think that that's pretty cool that the API for matplotlib is so nice, because I don't know how else you would make something so simply that gives a pretty good representation of the data. I am surprised though at how not normal that is. Like, that's very surprising. Yeah, possibly. Are you guys still downloading your torrents over there? Yeah. So, just to give the thing that I've used this, all the concurrency stuff for most recently, I've used it in a lot of applications in the past, but most recently, I was looking at the issue of blind SQL injection. And for those of you who aren't web developers, SQL injection is where in a web application, they are generating this SQL query. And they're inputting your user-provided parameters into the query. So, you're saying select all from users where username equals blah and password equals blah, and I control blah. And by injecting SQL syntax into that statement, I'm able to alter the way that the SQL is interpreted, and I'm able to alter the results of that. And what happens a lot of times is that you can't do that in a very useful way. So by altering the SQL syntax, I might be able to cause an error to happen, or I might be able to cause an error not to happen. And by injecting logic, so if all you can do is determine whether or not an error is going to happen, you can still inject logic, and you can essentially do a binary search. So I actually didn't mean to go too far into this. But, so, All right, so just something simple like this. All right, so for people who aren't very familiar with SQL, what we're doing is we're selecting all the user objects from the database where the user ID is equal to the username that's provided up here. Here it's Bob, but see how the user here is encapsulated in single ticks. What happened if we put a single tick in Bob? We just made an error in our SQL statement because now we have an unterminated string in the SQL query because this is going to evaluate to that instead of that. So what we can then do is we can start putting in other syntax. So you can say if username is equal to Bob or select user, and then we can take a substring of that. We're going to take the first character. Oops. Shit, I just deleted all that, didn't I? Is it? Do I have? Oh, I did multiple desktops. All right. Take the ASCII value of that. So now you've just selected the first string of the username of the user that's running the database and converted that to an integer. And you want to say we're going to be logged into the application if that value is greater than 123. So if the first string of the username of the user running the database is greater than 123, we will get logged into the application because Bob is a valid user. If we switch this to the opposite sign, then we will not be logged into the application. This is what's known as blind SQL injection. And if I was planning on talking about this, I would have done a slide rather than writing that up on the fly. If that makes sense, great. If it doesn't, it's not terribly important. But either way, you can see how you can start to do a binary search then to figure out what the value of the first letter of the username is. And then you can move on to the second character and the third character and the fourth character. And that's really time consuming. That's where I'm talking about having to do tons and tons and tons of requests if I want to dump a whole database with SQL injection. So there's some tools out there that are pretty shitty, and I wanted to write a better tool. So anything with lots of ASCII art, I think, is pretty sweet. So the problem that I had with all the other tools is that they were all synchronous. So when you have these, 100,000 requests to make, and it can be way more than that. Like if for work, like I said, I do this legally, but I'll dump databases with hundreds of thousands of records in it. I have to make 15 requests per character. If each row has 100 characters, that's a huge number of requests that we're talking about. So if you're dumping a big database, this can become a serious time issue. And again, do this with the permission of the database owner. So here on that same server, I've got a script that's vulnerable to SQL injection. You're welcome to go dick around with it if you want. It's kind of hardened, but so that's all configurable. You can specify the syntax. You see this is somewhat similar to what I was demonstrating earlier. I can blow that up. You can specify all that syntax to determine what you're going to dump from the database. I've got a couple different search algorithms that I do. So earlier I was talking about how you might get logged into the application or not logged into the application. It might be that there's a 1 byte difference in response size instead of that being the difference of whether or not you get logged in. It could be that you have to insert a sleep statement into the SQL query, and the only way that you can tell if your query evaluated is true or false is based on the response time. SQL injection, for how idiotic it is and how easy it is to remediate, it's still a huge problem, but we have a lot of fun dumping databases. So what I did here is then I wrote another, this is a very extensible program here, and it's possible to add hooks. So before every request goes out, you can have it call into your own function, and your own function can mutate it or whatever. So if you need to have all of your requests be HMAC signed or something, you can specify that real simply. So I wrote some hooks to do call out to that logging application that I just showed you. This is what one of the hooks looks like. So it receives the response from the server, and then it just sends it off to my plotting server. So I'm going to real quick see what's in my database. All right, so yeah, that looks good. I'm going to zoom out a little bit. So right now, it's taking about, like I was talking with the binary search, for every character that we're dumping from the database, it takes about 20 requests currently, going at about 2 characters per second. And if, and that looks like shit, I'm sorry. But if anyone's ever used, does any security stuff, and if you've ever used something like SQL Map for dumping databases, even this on this slow network with me making all these extra requests is still way, way, way faster. So this is making tons and tons of concurrent requests. I'm going to real quick modify my config file and show you it's a lot faster without the calls into this logging server. So it's reasonably performant. It's about 20 or 30 times faster than the existing tools, and I think that's a pretty good performance boost. And it's also, I think, way more versatile. So if we hop back over here, we now have more data. Okay, and this I think is going to actually be a little bit more normal. I didn't dynamically do the, whoops, oh shit. So yeah, I think this data is going to be a little bit prettier than the last data. So, and I didn't actually. I should have written some. Oh, Jesus. I'm not a web developer. I break stuff. I don't build stuff. All right. Did I forget to put in a max? Oh, whoops. I'm
You didn't check that?
No, I didn't. I know. So either way, I don't know. I think that this. So yeah, you see some slightly negatively skewed, but overall fairly normal distribution. I think that's kind of cool to be able to get that. I mean, between that logging server and the little hook that I wrote, which is 3 lines, I think that's pretty cool. I think that Matplotlib is pretty awesome for being able to provide you with that nice graph with that little of work. This is just something I hacked together last night, so I think that's pretty nifty. I don't know anything about statistics. If we feel like letting this go out, there's a nice ASCII art thing of a hamburger right down here. We'll let that go. That's it for my presentation. Does anyone have any questions? Caesar?
What's the Python rocket in the doc?
Oh, that's just Python, yeah. Oh, this is terminal too. Yep. Patching works well? Yes. Otherwise, no. So for things to be thread safe, there's a lot of things that you have to do when you're developing it. For things to be G-event compatible, yep, there's a lot of things that you have to do. So those things don't really mesh too well together, but there might be some middle ground where they play nice together, but for the most part, no.
Okay. No. I mean, there are things with like these event frameworks.
Crunching is not at all a good use case for G-event because it's not really blocking, it's actually doing computation. So yes. Oh, for sure, yeah. What I would do for something like that is I'd use like RabbitMQ or one of the messaging queues and then just have a different processor, a different thread or something for that, but yeah. Caesar?
So,
to be a web developer, but I thought it was more fun breaking stuff, so. And there's our hamburger. So yeah, that's it for me. Thank you guys for listening.
Any questions for Ben?
I've worked with is multiprocessing, multi-threading, and event-driven concurrency. Multiprocessing, you literally have multiple processes, so you write an application and then you spin up multiple processes to deal with the incoming request or the outgoing request, depending on what you're trying to do if you're writing a networking application. All these processes are running in their own address spaces. This makes it a little bit challenging to do communication between them if you're generally you need to maintain some state across the processes to kind of keep everything organized. So there's a lot of methods for this. You can have files for communication. You can do sockets, queues, pipes. For example, you have to be able to take more than one request at the same time, or else you're going to have a pretty hard time serving up to a large number of people. More specifically, you're trying to get around the problems when you have blocking. So things that normally block would be file access or file read and write, or network access, network read and write. So there's a lot of different techniques for this. I'm going to talk a little bit about some things at a high level, and then I'm going to talk a little bit more in depth about G-Event and Node.js, which are some things that I've been hacking on lately. So yeah, the options that I see, I don't know kind of what your guys' knowledge base is for this, but it's something that when doing networking and web application assessment tools I run up against all the time, is how to send out 100,000 requests in a reasonable amount of time when talking to a web server or any other server for that matter, and doing any other networking. So concurrency in general is notoriously difficult to get right. It's gotten a lot easier recently, but it definitely has a bad reputation, and I'll talk a little bit about why that is. So concurrency is simply doing multiple things at the same time. So if you want to run a web server for... All right, cool. I'm going to get started then. Can I get a quick show of hands? How many people here are web developers, Django people? Okay, so there's a decent representation. How many people are doing scientific computing or more of the matplotlib type of stuff? Okay, and then anyone just developing tools and hacking around and... Okay, cool. So I'm definitely in the last category there. I had never used matplotlib before like 2 days ago, but I tried to work it in here. I've been wanting to give this presentation for a while, but things always come up, so. I am Ben Toews. I work at a company called NeoHapsis. We're a local Chicago consultancy. I am an application and network penetration tester. I break web applications and native applications trying to find security vulnerabilities. I also do a lot of research. In the past year, I've presented at DEF CON. I'm going to be presenting at DerbyCon in a couple of weeks. I did ThoughtCon. I've gotten published a few other places. And throughout all of this, I heavily use Python. I've been doing Python for about 10 years now, so it's kind of my weapon of choice. So I'm going to talk to you guys a little bit about concurrency.